Good afternoon, everyone, and welcome to our live coverage of another Rocket Lab Electron mission from Rocket Lab Launch Complex 1, Mahia, New Zealand. Today, we are on the brink of witnessing another monumental event in the realm of space exploration. We are awaiting for the 50th Electron liftoff at 6:13 a.m. New Zealand Standard Time for French Internet of Things company Kinéis, which will be launching Internet of Things nanosatellites on a mission named No Time Toulouse. Today's mission will launch first batch of the 5 nanosatellites of its own constellation of 25 nanosatellites in a low polar orbit, or you can say low Earth orbit. This launch marks Rocket Lab's amazing 50th overall launch and 8th mission of this year. And with this mission, Electron will reach its 50th launch faster than any commercially developed rocket in the history, breaking the record previously held by SpaceX Falcon 9. Hello, my name is Dipta Maitra, performing the commentary for today's mission launch. We are super excited bringing you the coverage of Rocket Lab's No Time Toulouse Mission, dedicated first mission launch for Kinéis Internet of Things nanosatellites. The mission is the first of 5 dedicated Electron launches for Kinéis. Across these 5 launches, Rocket Lab will deploy Kinéis' complete constellation of 25 satellites. Now, before getting into the mission details, just a quick update. Teams from NASA and Boeing Space are targeting now on June 25th at 22:10 hours Eastern Time for the undocking of Starliner spacecraft from International Space Station and landing early about 4:51 a.m. Eastern Time on June 26th at White Sands Space Harbor in New Mexico. And secondly, the much anticipated US ISS spacewalk 90 will now be performed by NASA astronaut Tracy Dyson and Mike Barrett on June 24th, where Mike Barrett is replacing Matt Dominic in his current role. Just a heads up, it's just me running the show for our launch coverages, so if we hit any technical snags, hang tight, but don't worry, I will do my best to walk you through the Electron launch happening in just a couple of minutes. Now let's get back to today's mission. So far, Rocket Lab reports that the weather is looking good for today's Electron launch opportunity and the range is ready to support. We hope that they are able to launch on time and not have to push too far. Although this mission has a 14-day launch window that opens on June 19th. Rocket Lab is currently targeting a liftoff time of Electron from Mahia, New Zealand at 6:13 a.m. New Zealand Standard Time on Friday, that is 21st June, which will be at 2:13 p.m. Eastern Time, 11:13 a.m. Pacific Time and 6:13 p.m. UTC on Thursday, 20th June. Firstly, we express our gratitude to everyone for joining us and being a part of today's launch. We really appreciate you being here. Now, as we have some time before the webcast to begin, let's learn about our very own Electron in details. Electron that's supporting today's mission is a orbital class reusable 3-stage rocket which is 18 meters tall and 1.2 meters wide. An orbital launch vehicle designed specifically to place small satellites of up to 300 kilograms, that is 660 pounds, into a wide range of low Earth orbits. Every aspect of Electron has been designed for frequency and reliability to meet the evolving need of government and commercial small satellite operators. Electron's payload fairing protects the payload from encapsulation through flight. The fairing is 2.5 meters tall and 1.2 meters wide, and the fairing separation occurs usually pneumatic unlocking using springs. It can deliver 200 kilograms to 550 kilometers on sun synchronous orbit. Electron's payload fairing is a composite split clamp shell design and includes environmental control for the payload. During separation, each half of the fairing is designed to rotate on a hinge away from the payload, resulting in a safe separation motion. Expanding and tailored fairing options are also available depending on customers' need. Now, Rocket Lab's Kick Stage offers our customers unmatched flexibility for orbital deployment. The Kick Stage is a third stage of the Electron launch vehicle used to circularize and raise orbits to deploy payloads to unique and precise orbital destinations. The Kick Stage is powered by Rocket Lab's in-house designed and built Curie engine. In its simplest form, the kick stage serves as in-space propulsion to deploy payloads to orbit. Its most advanced configuration, that the kick stage becomes Photon, Rocket Lab's satellites bus that supports several year duration missions to low Earth orbit, middle Earth orbit, lunar and interplanetary destinations. Rocket Lab's Kick Stage is designed to deliver small satellites to precise and unique orbits, whether flying as dedicated or rideshare on Electron. Now, here are some requirements based on which Kick Stage missions are required. So, first of all, we have that if any mission where deployment of payloads at multiple planes and inclinations, including constellations, are required. Secondly, higher altitude deployment, inclination out of range of launch vehicle, missions which requires hosted payload support, multiple trajectory changes, sustain low altitude orbits, and deorbiting. The kick stage is a streamlined path to orbit that eliminates the added risk, complexity, and cost of having to develop own spacecraft propulsion or using a third-party space tug to deliver spacecraft to the desired orbit when flying as a rideshare. For missions that requires extended payload support on orbit, or for missions exceeding 2000 kilometers to middle Earth orbit, lunar or interplanetary destinations, Rocket Lab offers the Photon spacecraft bus, a high-performance evolution of the kick stage. Now let's take a closer look at Rocket Lab's kick stage, a marvel of modern aerospace engineering. The journey begins with the kick stage separating from second stage, a critical maneuver that sets the stage for what's to come. Imagine the precision required as the kick stage engine ignites, circularizing the orbit. With the orbit circularized, we are at a pivotal juncture in the mission. It's a moment of perfect alignment where the satellites are poised for their grand entrance into space. Then comes the payload separation, a thrilling instant where the satellites are released to their desired orbits. But hold on, the mission doesn't end there. In a responsible twist, the kick stage performs a final engine burn to lower its altitude, gracefully bowing out of orbit. This not only marks the successful end of the mission but also showcases Rocket Lab's commitment to space sustainability. Traditional methods of deploying satellites can leave large rocket stages in orbit, contributing to global issues of space debris. The kick stage has been designed with the capability to deorbit itself on an accelerated timescale well before the 25 years deorbit guidelines stipulated by NASA. By performing a deorbit burn with the Curie engine, Rocket Lab can lower the kick stage perigee to increase aerodynamic drag on the spacecraft and cause it to deorbit within months or single-digit years as required. Again, we would like to thank all of you for joining us for today's launch and would request that if you haven't already, please like this video to help YouTube's algorithm bring in more space fans and rocket enthusiasts. Also, it would be so kind of you subscribing to our channel. Now below the kick stage we have Electron's second stage. Electron's second stage consists of a single vacuum optimized Rutherford engine and linear less common bulkhead tanks for LOX, that is liquid oxygen and kerosene. With an expanded nozzle, Electron's second stage engine produces a thrust of 5,800 pounds of force and has a specific impulse of 343 seconds. The 1.3 meter diameter, it is 1.2 meter diameter second stage has approximately 2000 kg of propellant on board. The second stage has a burn time of approximately 5 minutes with the Rutherford vacuum engine as it places the kick stage into orbit. High voltage batteries provide power to the LOX, that is the liquid oxygen and kerosene pumps, for the high pressure combustion, while a pressurant system is used to provide enough pump inlet pressure to safely operate. During the second stage burn, two high voltage batteries will power the electric pumps until depletion, while a third high voltage battery will take over for the remainder of the second stage burn. Upon depletion, the first two high voltage batteries are jettisoned from Electron to reduce mass and increase performance in flight. The engine thrust is directed with electromechanical thrust vector actuators in two axes. Roll control is provided via a cold gas reaction control system, that is also acronymed as RCS. Now next we got the Electron's first stage just below the second stage. Electron's first stage consists of 9 sea-level Rutherford engine linearless common bulkhead tanks for liquid oxygen and rocket grade kerosene, that is RP1 propellants, and an interstage. Rocket Lab's flagship engine, the 5,600 pounds of force, which is equivalent to 24 kilonewtons of force, Rutherford engine is an electric pumped LOX and kerosene engine specifically designed for Electron launch vehicle. Rutherford adopts an entirely new electric propulsion cycle, making use of brushless DC electric motors and high-performance lithium polymer batteries to derive its propellant pumps. This cuts down on much of the complex turbomachinery typically required for gas generator cycle engines, meaning that the Rutherford is simpler to build than a traditional engine but can achieve 90% efficiency. Rutherford is also the first oxygen or hydrocarbon engine to use additive manufacturing for all primary components, including the regeneratively cooled thrust chamber, injector pumps, and main propellant valves. The Stage 1 and Stage 2 Rutherford engines are identical, with the exception of a larger expansion ratio nozzle for Stage 2 for improved performance in near vacuum conditions. All aspects of the Rutherford engines are completely designed in-house and are manufactured directly at Long Beach headquarters in California, USA. Now let's unpack some key features and milestones of this incredible spacecraft in a pictorial form. Here is a quick overview of Electron. Now let's move on and take a look at today's payload. With today's Kinéis IoT satellites, and from now I will be denoting Internet of Thing. Today the satellites are actually the Internet of Things satellites, so instead of mentioning every time Internet of Thing, I will be mentioning them as IoT. So with today's Kinéis IoT satellites launch, the primary mission is to provide connectivity for the Internet of Thing IoT everywhere on Earth. It will therefore be filling the gap that currently exists in the absence of terrestrial networks and providing this in near real time. A secondary mission is also on board. This is a system for collecting from orbit navigational aid messages exchanged between ships for anti-collision purposes. This system is also known as Automatic Identification System and acronymed as AIS. These messages provide regular information on the trajectory, that is the position, heading, speed, route, and miscellaneous things, and traffic status of ship in a given maritime zone. In case of today's mission, it will launch 5 nanosatellites, each weighs just 28 kilograms, and in total the payload weighs 150 kilograms. It is the first satellite launch for Kinéis, a provider of IoT connectivity via satellite, and also the first of Kinéis' complete constellation of 25 satellites. There will be more 4 upcoming launches to complete the constellation of these 25 nanosatellites. Now the antenna system is one of the special feature of the Kinéis satellites, in particular the double UHF S-band self-deploying antenna. The size of nanosatellites meant that a new concept of small foldable antenna had to be designed and developed. Now on your screen you can see the UHF antennas, how they look, and the AIS antennas. So the dual UHF-S antenna meets these requirements, consisting of a foldable UHF antenna to which a rigid S-band antenna is attached. The deployable UHF, that is ultra high frequency antenna, is dedicated to IoT connectivity, whereas the S-band antenna, designed and produced by Cobham Aerospace Communication, communicates with the 20 ground stations in the Kinéis system to relay mission data collected on board. Another demonstration of innovation is the AIS, that is Automatic Identification System antenna, which features a disruptive technology developed specifically for the second Kinéis satellite mission, that will be an upcoming mission, and it is dedicated to the maritime automatic identification system and anti-collision system. Now with its 2 solar panel deployed, it measures 1.40 meter in height and 1.60 meter in length. So you can say you can almost hug it. Today's payload will be placed at an altitude of 635 kilometers initially, with an inclination of 98 degrees. The constellation will be positioned in the low polar orbit, that is low Earth orbit, at an altitude of 650 kilometers. For a total of 25 nanosatellites, the Kinéis constellation is made up of 5 equidistant orbit planes around the Earth, with 5 satellites occupying each plane equally. And for this very choice of orbital placement, it will have a latency of less than 15 minutes between successful satellites passes, which is guaranteed at any point on the globe, facilitating to take advantage of nearly 80 daily passes. The Kinéis constellation is scheduled to last for upcoming 8 years. Also, the presence of electric thrusters on board the satellites enable 4 actions to be taken. Firstly, positioning the satellite in its orbit after separation from the launcher, maintaining the satellites in orbit, then to have the debris avoidance maneuvers, and lastly to deorbit when the nanosatellites has to be disintegrated in the Earth's atmosphere at the end of its life. The electric thrusters are powered by two solar panels, enables each nanosatellite to maintain its defined orbit and therefore the kinesis system to maintain permanent coverage accuracy. Now on your screen you can see the satellite's characteristics. Most of them I have mentioned, but just couple of things more to explain. The star tracker photographs the space environment within its field of vision to determine each satellite's location, altitude and orientation. It has onboard star mapping that enables it to see how the satellite is oriented in its orbit so that it can correct itself if necessary. The star tracker also includes an innovative component developed by Southern. Southern has developed a smaller but high performance optical head for the mini micro satellite range and has miniatured the electronic board controlling the star tracker. Each satellite contains reaction wheels providing agile attitude control for the vehicle. Both of these are same things which are there in Starlink satellites as well. The satellites are custom developed for the Internet of Things with strategic partners. Thales Alenia Space for contracting authority, Mahia for development and manufacture of the platform, and Links for the construction of the payload. Now let's take a look at how the constellation will work. Kinesis modules are small, 20 centimeters by 3 centimeters, low power and quick to integrate. Open source code and design libraries makes it possible to recreate a Kinesis module in a new object with a customized design. This constellation of nanosatellites, the basis of Kinesis connectivity, is unprecedented and is custom developed for Internet of Things. This will be operational 24 hours a day, 365 days of a year, and these operation centers will process data from future Kinesis constellation. With this, you are always connected and your objects are also connected as you travel across the world. But in one click, you have access to their location and to all the data collected by your sensors. Now, we have a request. If you are feeling we are adding value to your viewing experience, please consider giving this video a like, which really helps YouTube's algorithm to bring in more space fans and to people to find out this stream. Also considering subscribe to us as we strive hard to bring streams filled with stats and details. We would be super grateful for your support. Now let's have a look at the bar graphs with number of Electron launches each year. Before today's launch, rocketlab completed 7 launches of Electron so far this year as part of its milestone, with recent NASA's Pre-Fire and ICE mission launch back on June 5th. That was Rocketlab's 49th mission overall. This year's count already surpasses the total number of Electron launches from all the years leading up to 2021, and they are now getting close to launches made in 2022 with only 2 launches to go. Now with today's mission launch, the bar graph depicts 8 Electron launches so far this year. That's just one less than the number of launches in 2022 and 2 less than the number of launches last year. But today's launch is a special one as it marks Rocket Lab's 50th launch since Electron mission began in May 2017. Also, today's launch is a record breaker as Electron will be reaching its 50th launch faster than any other commercially developed rocket in history, a position previously held by SpaceX Falcon 9. Now we are approaching closer to the webcast to begin. So meanwhile the webcast is starting, let's just have a look at the flight profile for today's launch. Starting at well, let me say you something there is which has to be mentioned, that let's today's mission, which is somewhat distinct from other Electron launches as it is specifically tailored for Rocket Lab's customer, that is Kinesis. So let's have a look at that flight profile. As we have liftoff at T0, just 54 seconds into flight, the vehicle goes supersonic. At T plus 1 minute and 6 seconds, the rocket reaches max Q, the point of maximum aerodynamic pressure. Then there will be a couple of these different events in rapid succession. At T plus 2 minutes and 24 seconds, we experience main engine cutoff, that is MECO, on Electron's first stage. Just 4 seconds later, at T plus 2 minutes and 28 seconds, stage 1 separates from stage 2. At T plus 2 minutes and 31 seconds, the Rutherford engine on the Electron stage 2 will ignite. Coming up at T plus 3 minutes and 7 seconds, the fairing separation will be happening. At T plus 6 minutes and 19 seconds, we will have the battery hot swap. Next, at T plus 8 minutes and 58 seconds, we have second engine cutoff, that is SECO, on stage 2. Just 4 seconds later, at T plus 9 minutes and 2 seconds, stage 2 separates from the kick stage. As we near the end of the first phase of the mission, at T plus 52 minutes and 5 seconds, the kick stage Curie engine will ignite first time in today's flight. And from this point only, the flight profile is custom tailored for Kinesis. This Curie engine will burn This Curie engine burn will last for approximately 2 minutes and 40 seconds. Shortly after, at T plus 54 minutes and 45 seconds, the Curie engine cut off for the first time. Again, at T plus 1 hour and 3 minutes and 57 seconds, the kick stage Curie engine ignites, this time the second time in today's flight. Then at T plus 1 hour, 4 minutes and 5 seconds, the Curie engine cuts off for the second time in today's flight. Finally, at approximately T plus 1 hour, 6 minutes and 35 seconds, we will have the payload deployment completion for all 5 satellites. The tailored mission parameters for this launch include instantaneous launch window. Secondly, after the first Curie engine burn to circularize the kick stage orbit, Curie will ignite again for an 8-second burn to set a specific argument of perigee, enabling Kinéis to deploy 5 satellites to a precise location for each one of the 5 launches. All 5 satellites will be deployed in a precise sequence in singles and as pairs to build out the constellation exactly as Kinéis needs it. And finally, Curie will conduct a perigee lowering burn to reduce the kick stage orbital lifetime to keep the space sustainable. So let's check whether the stream is starting or not. Still they are saying waiting for rocketlab. So until we are waiting, let's discuss further. Meanwhile, we would like to welcome Pop Tripika, who came to visit us after a long time. And yes, this is the first launch attempt for Kinéis and as a company also, and also for their upcoming, like a total of 5 launches they have contracted with rocketlab. So this one is the first one of them. And as I mentioned, excuse me, and also as I mentioned that it is the first of the Kinéis launch as a company as well. Yes, today there will be no recovery of booster, I think, and I don't think, I am pretty sure about that, they will be expanding the booster. There will be no recovery of the booster. Previously also for the NASA's Pre-Fire and ICE, we didn't saw any booster recovery. So moving on, as we are getting close, maybe they will start the live stream sooner. Let's look into some stats. So as we look at the mission's progress, let's look into some mission stats for today's launch. This marks the 50th overall launch for rocketlab, showcasing their consistent excellence in the field. It's the first Kinéis satellite launch out of 5 planned launches for their constellation of total 25 IoT, that is Internet of Things, nanosatellites. Moving on to the launch frequency. This launch marks the 50th Electron launch to date, and which is a testament to Rocket Lab's rapid advancement in the technology and dedication to exploration, reaching its 50th launch faster than any other commercially developed rocket in history. Also, this will be the 45th Rocket Lab's orbital launch to date. With this launch, we will witness an impressive 8 Electron launch and Rocket Lab's overall launch this year. I guess they have started the stream, so let them be live and we will be switching to the stream. Until then, let's continue this discussion because they will take some time every time they do so. So moving on, speaking of the launch site advancements, this will be the 20th orbital launch from Pad B of Launch Complex 1 from Mahia, New Zealand. Also, this will be the 46th overall orbital launch to date from Rocket Lab's Launch Complex 1, which is a milestone that speaks volume and reliability. Also, capability of the launch facilities. Also, let's not forget there will be no first stage booster recovery plan for this mission, a strategic decision based on mission requirements. Now, if you feel that we are enhancing your viewing experience, again we request that please consider liking this video. It helps YouTube's algorithm attract more space enthusiasts to discover this stream. Also consider about subscribing to us as we work hard to provide streams filled with stats and details. Now moving on, let me walk through the impressive overall Rocket Lab stats that underscores this launch. With the No Time Toulouse Mission, Rocket Lab marks its 50th overall launch and Electron launch to date, a testament to their relentless pursuit of excellence and innovation. As we dive deep into the numbers, it's heartening to see 45 orbital launch and 1 suborbital launch success to date. Each successful mission is a beacon of hope. Yet, the journey of Rocket Lab is not without its challenges. Rocket Lab has faced 4 orbital launch failures to date, but these setbacks are not defeats, they are lessons that paves the way for future triumphs. Rocket Lab has achieved 7 ocean recovery successes for first stage booster to date, showcasing their commitment to reusability and sustainability. Adding to their list of achievements, Rocket Lab has successfully conducted 2 aerial capture tests of the first stage booster with recovery helicopters. This innovative approach to recovery is a glimpse into the future of spaceflight. Also, 2 successful controlled atmospheric re-entry tests were conducted to date. And not to forget, the 38 non-recovery of the first stage booster instances, which includes today's launch as well. And with this launch, it will be the 190 satellites launched by Electron to date. Also, 499 Rutherford engines sent to space. Each Electron launch features 10 Rutherford engines, as I mentioned before while I was mentioning the Electron launch vehicle. So including 9 on the first stage and the single vacuum engine optimized Rutherford engine on the second stage. Rocket Lab successfully flew a recovered Rutherford engine back in 2023. So the number is 499 engines rather than 500. Now just for a background, Rocket Lab operates 2 launch sites comprising a total of 3 pads for Electron launch vehicle. 2 launch sites, that is Pad A and Pad B of Launch Complex 1 located in Mahia, New Zealand, and another Launch Complex 2 at Mid-Atlantic Regional Spaceport within the NASA Wallops flight facility in Virginia. Now let's move on to the webcast as it began. We will be continuing the discussion further on later on in today's launch. Yes, Rocket Labs. I'm referring to Pop Tripica. Rocket Labs mission names are always a little bit of different, and I also cherish them. They are a little innovative and creative, as you say. Guys, please pardon me for muting this volume as because these are copyrighted tracks and maybe it can give us some copyright claims which we don't want. So let them be done with this music and all, and I will be making the track back on live. Meanwhile, we will be thankful for Robert Jasmer for subscribing to us.
A Rocket Lab Launch Complex 1 waiting to make its debut launch to space. And standing in its place now is our 50th Electron rocket, ready to make its way to low Earth orbit in just 40 minutes or so. Hello, I'm Muriel Baker, and today I am joining you live from inside our Mission Control Center as we celebrate our 50th liftoff with the very people who design, build, test, and launch our Electron rocket. Bonjour aussi et bienvenue to our launch customer today, Kinéis, an Internet of Things company from France. Today's mission is called No Time Toulouse in a nod to the name of their home city. And liftoff this morning is set for just after 6 a.m., 6:13 local time and 6:13 UTC. This mission is a special one for our team as it's our 50th Electron launch since our very first mission in May 2017. Now, Electron has had been a record-breaking rocket since its debut by being the world's first carbon composite orbital rocket, as well as the first rocket powered by 3D printed engines and electric pumps instead of traditional gas turbines. And with this 50th liftoff, we are set to break another record because Electron has reached 50 launches faster than any other commercially developed rocket in history. A huge achievement for our team that is testament to their dedication and tenaciousness in making dedicated, responsive access to orbit a reality for small satellites. And here to tell us more about the milestones along the way to 50 launches are my colleagues Prachi and Jamie.
Thanks, Muriel, and thank you all for joining us today. My name is Prachi Sakhnani.
And I'm Jamie Gilbert. It's great to be here on this really exciting morning for Electron and the whole Rocket Lab team.
Some days it feels like we've blinked and now we're at 50 launches, but the reality is we've packed a whole lot of complex missions, engineering evolution, and exciting achievements into these 7 years since Electron first took to the skies.
That's right, and we could tell you more, but we're going to go one better and show you instead.
So I started Rocket Lab in 2007 with one goal in mind, and that was to make space more accessible and more affordable for everybody. We are Rocket Lab. We are totally unreasonable people doing totally unreasonable things. You see, space is now open for business. Thank you very much. So with that, I think really there's only one more thing to do, and that's cut the ribbon and declare this launch site open. Right behind me here is the latest addition to the facility, Pad B.
And liftoff of Electron from Launch Complex 2, leaving US soil for the first time and on its way to space up and over the Atlantic Ocean.
Just now, what that launch you saw, it was of one of the launches, that is the Haste. I think I'm pronouncing right. That was the only launch Rocket Lab did, but never continued after that.
With number 50.
Now, before we get into the details for today's payload, it is time to check in with our operators on console and mission control for one of the final pre-launch polls. This is where our launch director will poll each of the operators to understand the status of their critical systems, including weather, avionics, guidance, range clearance, and more. If the operators confirm that their systems are green tracking green, this means they're in good shape for liftoff and everything is operating as planned. Let's listen in for those calls.
All stations LD on mission, proceeding with the status poll for launch sequence. Standby for poll for current and expected status for launch. Report green or red, tracking green or red for launch. Stage.
Stage is green, tracking green.
Avionics.
Avionics is green, tracking green.
GNC.
GNC is green, tracking green.
VCON.
VCON is green, tracking green.
T1.
T1 is green, tracking green.
GC.
GC is green, tracking green.
PLS.
PLS is green, tracking green.
RSO.
RSO is green, tracking green.
MET.
MET is green, tracking green.
MM.
MM is green, tracking green.
All right, thank you all. And MET, LD on mission.
MET.
Can you please provide a weather brief for T0?
Okay, so that shower we've been monitoring on the radar continues to move towards LC1, but it is weakening and the leading edge is dissipating. So we're looking at even later, more like 6:30 before it starts to affect LC1. POV remains 30%.
Copy, thank you, Matt. And T1 LD mission.
That's greens all across the board there, confirmed by launch director Michael Pearson. Today's launch is a special one for all of us, but especially for Michael, as it's his 50th launch on console. While we have a bunch of folks who have been on board with us since Flight 1, Michael is the only operator to have been on console for every single launch.
The launch director role is absolutely critical on launch day because the person in that seat needs to ensure that all teams remain on track for an on-time liftoff. They are constantly checking in with operators to confirm their critical tasks have been completed and then making decisions based on inputs from the team and a bunch of sensors too. And if any issues do crop up, they're charged with leading troubleshooting efforts and working them through to resolution before liftoff. So it's a big task, but Michael makes it look easy.
I guess you guys also heard that they are having some issues, although they said that it will be affecting the launch site at 6:30 p.m. There is some ongoing showers nearby, so hopefully it won't be affecting. Yes, Pop Tripica, let's go. Even I'm eager to have this launch because, as they said, this one is the 50th launch overall. So let's listen to them.
We call a 16U platform, so a bit bigger than a toaster, plus a cool antenna too, which weighs around 30 kilograms. And this means the total payload mass for today's Electron launch is around 150 kilograms, or about 308 pounds. So let's hear more from the team at Kinéis.
Kinéis is a French company based in Toulouse. We are a satellite operator and a global connectivity provider dedicated to the Internet of Things. Mountains, ocean, deserts. 85% of our planet has no network coverage. In 2020, we raised a large amount of 100 million euros to address this global issue. Today, we are following through and will deploy a constellation of 25 nanosatellites that will enable us to connect to a multitude of objects anywhere on the planet in near real time. We are convinced that this transmission of information made possible by satellite connectivity will enable us to respond to crucial challenges for mankind, its activities, and its environment. On the environmental front, for example, Kinéis connectivity can detect a fire outbreak in less than 15 minutes, thus considerably reducing the extent of the outbreak and reducing the loss of property and human life. The same goes for monitoring water levels to prevent flooding and use this dwindling resource. The applications are endless, whether for locating, monitoring, or alerting. Since the creation of Kinéis in 2018, our teams have been working with this objective in mind. Our 25 nanosatellites that weigh only 28 kilograms are real technological gems. The retractable UHF antenna, for example, can hear a bird sing within a rock concert 650 kilometers from the Earth. We fitted them with thrusters to ensure they stay on track for their mission. Some even carry children's drawings. That's amazing. At the same time, we have deployed many ground stations worldwide and have a sovereign infrastructure to guarantee data transmission to our clients. Today marks a significant milestone for Kinéis. Rocketlab will launch our first 5 satellites, which have been meticulously placed with millimeter-level precision under the fairing. Soon, it will be possible to locate and monitor various objects across the globe that address fundamental issues in our society. We can't wait to see the first steps toward our constellation. Thanks anyone, thanks to all teams.
We are so excited to get the first 5 of these Kinéis satellites into orbit just over 29 minutes from now.
Well, I forgot to mention that today's payload will be having some pictures drawn by some young peoples. Let me say that 15 young winners that are aged between 6 to 17 years of age, and they participated in the national drawing competition at France that was named Your Drawing in Space, that was organized by Kinéis and a government organization at the end of 2022, and the theme was Satellites for a Better Understanding and Protection of the Earth. And out of those, I guess 15 numbers of drawings, or you can say pictures, by those people, those kids. They will be also on today's payload. And as the chairman of Kinéis mentioned, I also mentioned it before, but let me just make it more clear, because you guys will be wondering what this Internet of Things is to do with the satellites. So Kinéis is mainly focusing about to make a device or a module, you can say, that is very much small, that is 20 centimeters by 30 centimeters, and is of very much low power and is quickly to integrate. So you can put it on your, just an example I'm saying, make it on your bag or in any place at your home or any on your device, even on your bathtub also. So just an example I'm saying. So those modules are open source code and design libraries that makes it possible to recreate those Kinéis module in a new object with a custom design also. So now they will be connected to those satellites. So and they will be operational 24 hours a day, 365 days of a year. Also, Kinéis data center will be processing data received by those modules wherever you are putting that module as per your convenience, and those data, as they are transmitting to the satellites, they are getting back to the data centers, they are getting processed and again feeding back to the satellites. From there you can access those data anywhere while you are traveling across the world. So this is the main concept of today's payload, what they are sending to space. So now let's listen back to them.
Just loved the purpose of that mission and what those satellites were aiming to do. And it was so exciting to be working with NASA and MIT Lincoln Labs. And on top of that one, I didn't manage this mission, but I think the first mission from LC2.
Flight 33, which was our first launch from LC2. That was years of work, you know, from a ton of people to make that happen.
All of the hard work that we've put in to launch Electron from New Zealand, bringing that to a new continent, and having new challenges and getting to all work together to achieve this goal, which was like such a huge goal for so long for this company. I'll never forget how much work that was, but how rewarding it was too.
I think my favorite mission name's got to probably be Baby Come Back, mostly because it got stuck in my head the entire time we were doing that launch campaign. Baby come back. Any kind of fool could be.
I think one of the main reasons for success has been the company culture. As we grew, we've always maintained this effort to keep the culture. And I mean, if you look anywhere here, everything looks high quality, everything looks beautiful. This sets the culture.
Rocketlab has a very unique camaraderie, and I think it's important to be able to go out to different sites, to New Zealand, to the US, to Wallops and so on. You have different cultures, different people combining ideas. On top of that, Rocketlab also allows you to take about as much responsibility as you can, right? So like the more responsibility you want, the more you can get as long as you kind of continue to produce. And I find that to be a very unique combination.
The barrier to entry is so high, it is a very tough challenge, and we had the right people at the right time at the right place to make it happen.
Everyone is harder than the next, but that keeps it interesting. So, you know, there's genuinely nothing I'd rather do.
I think my message to the foundational Electron team and the team that carries through right now is that, firstly, take a minute to be proud of what we've achieved. I think it's incredible to see what Electron was and is becoming. There's a lot of growth for Electron to continue. We've done things like interplanetary through to suborbital, and it feels like we're kind of, in some ways, just getting started for what Electron can continue to do. So just as we pioneered to bring Electron to market, I think there's just amount of pioneering and development to go moving forward to bring Electron to many other applications.
So my name is Cruz Shokura. I'm a vehicle integration technician at Rocketlab. I have been at Rocketlab for 3 days. I think it was just by chance that I started, and it was the 50th. Yeah, it'll be my first time seeing a launch this close, so I'm pretty excited.
Now clearly there has been a lot of hard work and dedication from a lot of people to make it to today's 50th launch. And another early Rocket Lab employee is Dr. George Buchanan, who has been part of Rocket Lab's guidance, navigation and control team since before Flight 1. Good morning, George.
Well, so I'm George Buchanan, and Yeah, I'm head of the guidance, navigation and control team these days for Neutron. So I started off in Electron. Before Flight 1, I was doing things like figuring out how many engines we should have. And these days I'm in Neutron and doing almost exactly the same thing again.
And how do you feel on today's launch of the 50th
There's good
Electron?
energy today. We've got so many people back here, but I'm still pretty nervous, to be honest. That hasn't gone away since Flight 1. The reasons changed, of course. Flight 1, I was really nervous because I didn't know if it was even going to go in the right direction. These days I'm nervous because the customers place so much trust and so much value in what we do. And so some of the payloads we're doing are really impactful to the world, and even if they're sort of part of a constellation, everyone's had so much effort poured into it. And so the customers deliver it to us, and basically after that it's fully on us to make sure it ends up in the right orbit. So it's a lot of responsibility, and I still feel that little sort of twinge of nerves and like, let's do this, let's prove why we're sort of one of the leading companies out there to do this.
If you're feeling those feelings, it means you care, right?
Oh, absolutely.
Now, earlier I mentioned that you are, in fact, an early Rocket Lab employee, and for context for viewers, each member of the team here gets a mission patch number for what time they join the team. We have about 2,000 people now in Rocket Lab, and Sir Peter Beck is mission patch number 1. George, what mission patch are you?
I've been here for 10 years, and I think I'm mission patch 12.
So a very long time you've been here, since before Flight 1, is that correct?
Well before Flight 1.
Yeah, wow. Now, you don't actually work on Electron missions anymore. That's where you started, but you now lead up the GNC team for Neutron, our new rocket. So what are some of the experiences you had with Electron that have helped prepare you for what you do now on Neutron?
Yeah, I mean, there are quite a few similarities, of course. It's still a rocket, so you still need all the basic algorithms to get it up into orbit. I guess the new things are twofold. So one of them is the technical side. So Neutron's fully reusable retropropulsive landing, and that's really hard to do. We've seen it happen before, but it's so intricate, there are so many details, and so having a rocket which can fly forwards at sort of subsonic, transonic, supersonic, hypersonic speeds, then flip around, re-enter in exactly the same regimes, it's one of the hardest challenges out there. And so leading one of the teams which is really key to this new functionality is incredibly rewarding, but we're learning a whole bunch as well, of course. And then the second thing is that when we developed Electron, we didn't really know what we were doing. Probably shouldn't say this live, but we're a bunch of pretty young people. We hadn't launched rockets before, and so we developed everything from scratch, which is great because we understand the rockets fully. But of course, now we're doing Neutron, and so we can take all of these lessons and apply them. And so we're doing a few things a little bit differently. It's actually not as different as you'll think. We did really well for Electron, but we can tweak a few little things here and there, make it more efficient, particularly so that we can ramp up and really do a huge number of launches quickly.
That's very cool. Do you have to be a mathematics genius to work in GNC?
No, I mean, we're not going to turn anyone away. If you're a mathematic genius, come and join us. But the GNC and flight software teams, we work really closely together. And we've already got a bunch of mathematic geniuses. We're actually a few roles open. Go to the website, have a little look. And sure, you need to be pretty able, but really what we're looking for is some good problem-solving skills. We're looking for people who are willing to dig into a problem and take ownership of it as well. And then, of course, just being sort of enthusiastic, willing to come in at 5 a.m. for interviews, willing to be on console and launch rockets. You need to be able to pick up anything and run with it.
Now, you're outside of Mission Control today, but you have spent plenty of time in the Mission Control Center on a console before. Do you miss it?
Say again?
Do you miss it?
Yes and no. I do miss it, particularly when the rocket lifts off and you sort of feel like, I did that. Whereas these days, of course, I'm working on Neutron and we haven't launched yet. That's coming up soon. But then the stress is pretty immense. Being on console is a funny thing because you're sitting there for hours before launch, and half the time you're not doing anything. You're sitting there monitoring everything absolutely carefully, but you're not actually actively doing anything. You're waiting perhaps for the propellants to be loaded. And so you're sitting there in this weird mixture of stress and relaxation. It's very unique.
Well, thank you so much, George, for joining us. And if you are interested in one of the guidance, navigation and control roles at Rocket Lab, like George did a good pitch for before, then you can come and join us. We have the open roles on our careers page on the Rocket Lab website for more info.
Sequence. The primary abort switch and watchdog are configured and ready. LD Sup, LD Mission.
LD Sup.
Please confirm the secondary abort switch and watchdog are configured and ready.
Can confirm.
Avionics, LD Mission.
LD Avionics.
Confirm stage 2 umbilical POF is nominal.
Confirmed.
And confirm HVB balancing is disabled.
Confirmed.
ComOps, LD Mission.
LD ComOps.
Please confirm video streams are in sync.
Can confirm video streams are currently in sync.
A check-in with the countdown clock, and we are just over 17 minutes to liftoff for today's mission. And as we prepare to watch Electron take to the skies for the 50th time, let's take a closer look at our record-breaking rocket.
A small launcher dedicated for small satellites, Electron was the first of its kind to reach orbit when it first took to the skies in 2017, opening up access to space for small satellite operators. Today, it is the second most frequently launched U.S. rocket annually. More than 180 satellites have found their home in space across 49 Electron missions, launched from Rocket Lab's Launch Complex 1 in Mahia and Launch Complex 2 in Virginia, USA. Designed, manufactured, and launched by Rocket Lab, Electron is a two-stage to-orbit launch vehicle powered by liquid oxygen and rocket-grade kerosene. It's the world's first carbon composite orbital launch vehicle, making it strong but still lightweight, and also gives Electron its sleek black look. The rocket is powered by 10 Rutherford engines, 9 at the bottom of the first stage and a 10th space-optimized engine to power the second stage to orbit. The Rutherford engine is the world's first to use an electric pump feed cycle for orbital space travel, making use of the electric motors and batteries to drive its propellant pumps. It's also 3D printed using additive manufacturing processes, another industry first. Electron is also equipped with a third upper stage, known as the kick stage, that serves as the last mile delivery to deploy multiple payloads to precise and individual orbits, even when flying on the same mission. It's to this kick stage that the 5 Kinéis satellites are attached, ready for deployment.
Today's launch will be our 8th launch of the year, putting us well on pace to beat last year's record of 10 launches. And it is lifting off from Launch Complex 1 on New Zealand's Mahia Peninsula, a launch site we built to enable high-frequency launch made possible by the very limited sea and air traffic around that site. It's the world's first orbital launch site and has played host to 45 of 49 Electron missions to date, with the remaining 4 launches taking place from Launch Complex 2 in Wallops, Virginia.
Referring to Pop Tropica, yes, we do have a Falcon Heavy upcoming launch that is for Goes U. Also, it is said as Goes U, actually it is GOES-U for NOAA. It is an organization who monitors the weather and ocean at US. So for that they will be launching a satellite. I guess that will be happening on 26th of this June. It's 25th of this June at the United States. And it will be launching from Kennedy Space Center, Launch Complex 39A. Now, as we have still 12 minutes to go, let's just discuss and complete about
T-minus 12 minutes and
talking about the stats. I will be hearing the comms. If anything important is coming up, I will be notifying you guys. So as I was saying that Rocket Lab, as you heard also from them, that they operate from 2 launch sites comprising a total of 3 pads for Electron launch vehicle, 2 launch sites, that is Pad A and Pad B of Launch Complex A located in Mahia, New Zealand, and another Launch Complex 2 at Mid-Atlantic Regional Spaceport within NASA Wallop's flight facility in Virginia. So now speaking of the stats, they got 26 launches from Pad A of Launch Complex 1 and 20 orbital launches from Pad B of Launch Complex 1, including one from today's mission. To date, there have been 4 orbital launches from Launch Complex 2 in Virginia. And to sum up, they got 46 orbital launches from Launch Complex 1 here in Mahia, New Zealand, which includes today's launch. Moving on to this year's orbital launches, including today's one, United States is dominating with 73 orbital launches, launch comprising a substantial 62.9% of the global total. China follows closely behind, accounting for 24.1% with 28 launches. Russia maintains a steady pace with 8 launches, making 6.9% of the pie, with the recent Soyuz 2.1A launch of ISS Progress 88 or Progress 27, that is the ISS cargo resupply mission on May 30th from Baikonur Cosmodrome. While Japan has 3 launches so far, making 2.6% of the pie, both India and Iran have entered the fray with 2 launches each, making 1.7% of the pie. Now moving on, the last stats we are having for today to discuss, that is 2024 orbital launches by rocket variations, including today's launch. So as this one is Rocket Lab's launch, so let's discuss about Rocket Lab first. So the yellow slice of the pie showing the Rocket Lab's Electron with 8 launches, making 6.8% of the pie, including today's launch. Then the big green slice of the pie, that's the Falcon 9 rocket, a real heavy hitter this year, having the biggest share of the pie with 61 launches. An upcoming launch is scheduled for later today, that is for SES Astra 1P mission, probably in just some hours from now if weather cooperates. The weather at Cape Canaveral is not going on so much favorable, so for that we did have to see 2 scrubs for the same SES Astra 1P mission. Hopefully they will be able to launch today, and we will be streaming the event as well, so don't forget to tune in. Next we have this pink slice labeled Others, which is a mix of different rockets including Delta IV Heavy, Starship, Atlas V, Vulcan Centaur, ISRO's GSLV Mark II PSLV-DL, Japan's H3, Iran's Simorgh and Kayam 100, Russia's Angara A5 and other launches. The names are not exhaustive. I'm not taking all the names here, but they got 33 launches in total, which is 28.2% of the pie, which is quite impressive. Also we have Soyuz 2.1A and 2.1B rockets with 7 launches so far this year, which is 6% of the pie. Last but not least, we got China's Long March 2D and Long March 2C rockets. These are also referred as CZ2D and CZ2C. So the Long March 2D has 5 launches, making 4.3% of the pie, and CZ2C, that is Long March 2C, has 3 launches with 2.6% of the pie. As we eagerly await the launch, let's celebrate the achievement and embrace the challenges that Rocket Lab has encountered.
Dream team. Now, if you've been following us for the past 49 missions, you'll know all about Electron and exactly what to expect from today's launch sequence. But if you're joining us for the first time, here is what you need to know. Electron is what's known as a small launch vehicle. It stands at 18 meters or 59 feet tall, and it can lift a payload with a mass of up to around 320 kilos or 705 pounds. Today's payload, though, is around half that mass at 150 kilograms. And the rocket is pretty lightweight too. Electron is the world's first orbital class rocket made from carbon composite material, which is incredibly lightweight for its strength, allowing us to maximize payload capacity, of course, but also giving Electrons their signature black look. Before Electron is fueled, it weighs just 1 ton. But once the tanks are filled with liquid oxygen and kerosene, it weighs more than 12 times that amount. So there you have it, Prachi. Rockets are really just flying fuel tanks with engines to move them in the right direction.
Yeah, pretty simple and very true, Jamie. Speaking of those engines, there are 9 3D printed Rutherford engines on Electron's first stage and a single vacuum optimized Rutherford engine on the second stage. Now, there is a lesser known 11th engine on every Electron launch as well, and it is known as Curie. The small but mighty engine is what enables us to maneuver the kick stage in orbit, including raising and lowering orbits to perfectly position satellites that we carry for deployment. Like many rockets, Electron's stages operate a bit like a relay race. The first stage, the single largest structure of the rocket, carries the mission for the first 2.5 minutes of flight, propelling us to around 80 kilometers in altitude. After that, the first stage separates and falls back to Earth in preparation for the second stage to take over the race. That single Rutherford engine on the second stage then burns bright for another 6.5 minutes, propelling us all the way to an elliptical orbit. And then the final leg of the journey is completed by the kick stage, which circularizes the orbit ahead of payload deployment. So now that you know what to expect, let's watch it all unfold in real time as we enter the final minutes of the count. How are we tracking, Muriel?
Hey Prachi, we are at 4 minutes 36 seconds remaining in the countdown to liftoff for No Time Toulouse, and operations are progressing smoothly as we inch closer to engine ignition for today's launch. Now at T-minus 2 minutes, Electron's flight computer will take over the countdown and autonomously run through the final operations. Good oxygen will continue to flow Electron all until T-minus 1 minute and 30 seconds. We hear a call from mission control when that happens, indicating that the lock system is in recirculation. Then after that, we'll hear confirmation that Electron's first and second stages are fully pressurized and ready for launch. Is to listen out for the final 10-second countdown from the launch director. We're going to hand it over now to mission control to listen into that final pre-launch sequence.
Those audio glitches were from their end, guys. I guess they have some issues with transmission. And yes, Bob Tripika, even I want to spell those words that Starship has this much of launches this year. But right now, as of this year, we saw only 2 integrated test flights. And I'm keeping a count of at least 5, minimum of 5 launches to display them on the pie chart. So let them hit that count, and this year we will be having more upcoming integrated flight tests.
All stations LD on mission. From now, there should be no red flags in your critical LCCs. VCON, LD mission.
LD VCON.
Lock auto sequence and confirm.
Auto sequence is locked.
Confirm all expected flight computer as goes are green.
That's confirmed.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
So we have a go for launch, the final go from the launch director. Hopefully what they were mentioning before about the weather, it won't affect now, as we are nearing only T-minus 2 minutes and 15 seconds counting. So just want to see the launch.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
The vehicle is now completely on internal power. Now those onboard computers and controllers will be handling the last minute of count before the liftoff.
Lock load is complete. System is in recirculation.
LOX load is also complete.
Anti-geyser in is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
Pressurization of tanks are complete also. We are just about 30 seconds from liftoff.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning pitch over.
And we have liftoff. Electron has cleared the tower.
Stage 1 propulsion
We are
nominal.
on our way to space. Our 50th Electron rocket has taken flight and is headed to orbit carrying 5 satellites for Kinéis. Now up next you will hear the call out for max Q, or maximum aerodynamic pressure, which is the point in flight when Electron experiences peak structural loads. The GNC operator on console will give us the call that max Q is approaching, and then we'll listen out for confirmation of that.
Max Q.
We should be expecting the max Q at T plus 1 minute and 6 seconds
Max
around.
Q.
Excellent to have that confirmation that we have passed through max Q. We are now at over 2,000 kilometers an hour in speed and just past 17 kilometers in altitude on our way to orbit for Kinéis. Now next up, there are 3 key events for the mission: main engine cutoff, or MECO, stage separation, and then stage 2 engine ignition. MECO is when all 9 Rutherford engines shut down simultaneously on the first stage to prepare for the next phase in flight. Then after those engines are off, Electron's first and second stages will separate. Stage 1 will return back to Earth, while stage 2 heads in the opposite direction and onward to orbit. Then the vacuum-optimized Rutherford engine on Electron's second stage will light up to propel the stage for this second phase of flight. Now, those 3 events all take place in quick succession over just a few seconds, so let's listen in for the calls.
15 seconds to staging. Entered burnout detect mode.
So we will be having the MECO at nearly t plus 2 minutes and 24 seconds, where the main engine will be cutting off on Electron first stage. Now that is confirmed. MECO is confirmed.
Stage separation confirmed. Stage 2 ignition confirmed.
3 successes and 3 milestones down. That was MECO, stage separation and second stage engine ignition. We are now more than 2 minutes into flight and on the way to orbit for Kinéis. And up next will be fairing jettison, when Electron's fairing splits in 2 and falls away.
We had MECO at, and just after that 4 seconds we got the fairing separation as well.
The call out for fairing jettison, in which you also saw on your screen, exposing the payload of Kinéis' 5 satellites to space ahead of their deployment. Electron is traveling at over 8,000 kilometers an hour and at an altitude past 126 kilometers. Just a couple more minutes remaining in this second stage burn.
Holding nominal.
Now upon we had MECO, just after 4 seconds we did got the stage separation, and just after 3 seconds the Rutherford engine on Electron second stage was ignited, and at t plus 3 minutes and 7 seconds around we had the fairing separation. Next, at t plus 6 minutes and 19 seconds we will be having the battery hot swap. Following that, we will be having at t plus 8 minutes and 58 seconds, where we will be having the second engine cutoff, that is the Rutherford engine cutoff on stage 2. So let's hear the call outs from them.
Is at least 28,000 kilometers an hour, so we have a little faster to go just yet.
On the left side of your screen you can see how the progress is going on as we are approaching the next milestone, that is the battery hot swap.
We are still partway through the engine burn on Electron's second stage, and one of the things that sets Electron apart from many other rocket designs is the use of electric pumps in the Rutherford engines. Now, those pumps are powered by batteries, which deplete as the engine draws power throughout the flight. But once we use up all that available energy in one set, we switch to a second set of batteries to complete the mission. And once they're dead, then they're gone, and we lose the batteries to drop the extra weight. Now, this clever little maneuver is referred to as the battery hot swap. Keep an eye on your screen to see those shiny silver batteries eject and fall away, and we should hear the call come from Mission Control soon.
HVB battery discharge nominal, approaching hot swap in roughly 30 seconds.
As you just heard, that during the second stage burn, there are 2 high voltage batteries that powers the electric pumps until depletion, when a third high voltage battery takes over for the remainder of the second stage burn. Upon depletion, the first 2
down.
high voltage batteries are jettisoned from Electron to reduce mass and to increase performance in flight.
Battery jettison confirmed.
So we got the confirmation.
50 seconds.
There we go, that was battery hot swap for the second stage Rutherford engine. The mission is continuing nominally at more than 16,000 kilometers an hour and now past 204 kilometers in altitude. And up next we will have the final phase of stage 2 flight, including SECO, or second engine cutoff, which is then followed by kick stage separation. And this is where the kick stage, which is carrying Kinéis satellites, separates from Electron's second stage. No, the final engine cutoff on stage 2 is coming up now, just shy of 9 minutes into the mission.
So we will be having the SECO, that is around T plus 8 minutes and 58 seconds, that is the second engine cutoff on stage 2, and following 4 seconds later only at T plus 9 minutes and 2 seconds, stage 2 separates from the kick stage with the payload on board. And as I was mentioning previously, today's flight profile is tailored.
The engine you see on your screen is actually our 499th Rutherford built for an Electron mission, not our 500th engine for our 50th mission like you might expect. And that is because while each Electron features 10 Rutherford engines, 9 on the first stage and 1 on the second stage, we actually recovered and reflew a Rutherford engine on an Electron mission for the first time in 2023. So today instead marks number 499.
Just under a minute.
So what I was saying that today's mission is having the flight profile is a little tailored, as because the Kinéis wants those profile to have for their launches. So after the first Curie engine burn will be there to circularize the kick stage orbit, Curie engine will ignite again for an 8-second burn to set a specific argument of perigee, enabling Kinéis to deploy 5 satellites to a precise location for each one of the 5 launches. That is those upcoming 5 launches, and all 5 satellites will be deployed in a precise sequence in singles and as pairs to build out the constellation exactly as Kinéis needs it. And finally, Curie will conduct a perigee lowering burn to reduce the kick stage orbital lifetime to keep space sustainable. So we did have stage 3 separation and also the
Great news there from Mission Control. The second stage engine has now shut down and the kick stage has separated. And that means Kinéis satellites are on the kick stage for a coast phase around Earth. Now, once it has looped back around, the 3D printed Curie engine on the kick stage will ignite twice to complete some final positioning maneuvers before the 5 satellites are deployed to their 653-kilometer circular orbit. All that remains now is to wait for those final Curie circularization burns scheduled at around T plus 52 minutes. Over to Jamie and Prachi to tell us what we can expect from that phase of the mission.
Thanks, Muriel. And yes, that's right. We're on the home stretch of our 50th launch. Right now, the kick stage is coasting around Earth in an elliptical orbit, gradually making its way to the apogee, or the point in orbit where the kick stage is furthest from Earth. Once it reaches that point, the Curie engine will ignite for 2 separate burns to raise the kick stage's orbit and circularize it to 650 kilometers above the Earth's surface.
Around 1 minute after that final burn, the Kinéis satellites will be deployed in sequence. First will be a single satellite deployed off the top of the kick stage, followed by the remaining 4 satellites deployed in pairs from opposite sides. So while we wait for that, enjoy the relaxing tunes from our good friend Tim Dodd, aka the Everyday Astronaut. We'll see you back here soon.
Your dude gives us copyright claims. We can make those musics to go on here. So let's move ahead and let's discuss our things while keeping an eye on the launch. So those who missed this payload details which I was mentioning before, today's Kinéis IoT satellite, that is Internet of Things satellites, they will be having the primary mission to provide connectivity for the Internet of Things everywhere on Earth. It will be therefore be filling the gap that currently exists in the absence of terrestrial networks and providing this in near real time. A secondary mission is also on board, that is a system for collecting data from orbit, navigational aid messages exchanged between ships for anti-collision purposes. This system is known as Automatic Identification System, acronymed as AIS. These messages provide regular information on the trajectory, such as position, heading, speed, route, etc., and traffic status of the ships in a given maritime zone. In the case of today's mission, it will be launching 5 nanosatellites. Each weighs just 28 kilograms in total, and overall the payload weighs 150 kilograms today. It is the first satellite launch for Kinéis, a provider of Internet of Things connectivity via satellite, and also the first of Kinéis' complete constellation of 25 satellites. The antenna system is one of the special features of the Kinéis satellites, which they didn't mention while they were saying all those stuffs in the stream. They should have been mentioned about the payload, that in particular the double ultra high frequency S antenna is a self-deploying antenna. The size of nanosatellites meant that a new concept of small foldable antenna had to be designed and developed. So on your screen you can see the ultra high frequency antennas, how it look and how the AIS antenna looks. So the dual ultra high frequency S antenna meets these requirements, consisting of a foldable UHF antenna, that is ultra high frequency antenna, to which a rigid S band antenna is attached. The deployable ultra high frequency antenna is dedicated to Internet of Things connectivity, whereas the S band antenna, designed and produced by Cobham Aerospace Communications, will be communicating with 20 ground stations in the Kinéis system to relay mission data collected on board. Another demonstration of innovation in the AIS, that is Automatic Identification System antenna, is that it features a disruptive technology developed specifically for the second Kinéis satellite mission, which is an upcoming mission. So it is dedicated to the Maritime Automatic Identification System, that is AIS, which is an anti-collision system. With its 2 solar panels deployed, it measures 1.40 meter in height and 1.60 meter in length. So you can almost hug it. Today's payload will be placed at an altitude of 635 kilometers initially, with an inclination of 98 degrees. The constellation will be positioned in the low Earth orbit at an altitude of 650 kilometers. For a total of 25 nanosatellites, the Kinéis constellation is made up of 5 equidistant orbital planes around the Earth, with 5 satellites occupying each plane equally. For this choice of orbital placement only, it will have a latency less than 15 minutes between successive satellite passes, which is guaranteed at any point on the globe, facilitating to take advantage of nearly 80 daily passes. The Kinéis constellation is scheduled to last 8 years. Also, the presence of electric thrusters on board the satellites enable 4 actions to be taken. Firstly, positioning the satellite in its orbit after separation from launcher. Secondly, maintaining the satellite in orbit. Thirdly, debris avoidance maneuvers. And lastly, the fourth action it can take, that is to deorbit when the nanosatellite has to be disintegrate in Earth's atmosphere at the end of its life, which is in accordance with the French law on space, acronymed as LOS. This LOS is not loss of signal, this is law on space for French. And the electric thrusters are powered by 2 solar panels, which enables each nanosatellite to maintain its defined orbit and therefore the Kinéis system to maintain permanent coverage accuracy. On your screen you can see the satellite characteristics. Two things which I didn't mention before is that the satellites have star tracker similar to those which we are having on Starlink satellites as well. So here the star tracker photographs the space environment within its field of vision to determine each satellite's location, altitude and orientation. Also, it has an onboard star mapping that enables it to see how the satellite is oriented in its orbit so that it can correct itself if necessary. The star tracker also includes an innovative component developed by Southern. Southern has developed a smaller but high performance optical head for mini micro satellite range. Each satellite contains reaction wheels which provides agile attitude control for the vehicle. As I mentioned before, both of these are the same things which we see in Starlink satellites as well. The satellites are custom developed for Internet of Things with strategic partners, where Thales Alenia Space for the contracting authority, Mahia for the development and manufacture of the platform, and Sirlinks for the construction of the payload. Now this is how the constellation will be looking when they will be revolving around the Earth. And this is the actual working procedure of the satellites with the ground stations and also with the Kinéis modules which I was mentioning. So the Kinéis modules, again I'm repeating myself, but Kinéis modules are small, that is 20 centimeters by 30 centimeters, low powered and quick to integrate modules. These are open source code and design libraries have making it possible to recreate a Kinéis module in a new object with a customized design. This constellation of nanosatellite, the basis of Kinéis connectivity, is unprecedented and is custom developed for Internet of Things. These satellites and the ground stations where the data will be processed will be operational 24 hours a day, 365 days a year. So your connected objects travel across the world, you can say it, but in one click you can have the access to their location and to all the data collected by those Kinéis modules on your preferred places by their sensors. Now as we are heading towards the kick stage performance, so let's just have a look at how the kick stage works. Kick stage, which is a marvel of modern aerospace engineering. The journey will begin with the kick stage separating from second stage, a critical maneuver that sets the stage for what's to come. Now just imagine the precision required as the kick stage engine ignites as it circularizes the orbit. Just when the payloads are being separated from the kick stage, they are revolving in an elliptical path around the Earth. So those elliptical paths of the satellites have to make them back on the in a circle around the Earth. So that's where the kick stage comes into the work. So with the orbit circularized, we will be at a pivotal juncture in the mission. It is a moment of perfect alignment where the satellites are poised for their grand entrance into space. Then comes the payload separation, a thrilling instant where the satellites are released to their desired orbits. But the mission does not end there. It is still having the third and the final engine burn as of today's flight to lower its altitude, gracefully bowing out of orbit. This marks the successful end of the mission and also showcases Rocket Lab's commitment to space sustainability. So referring to Poptripika in our chat, no, actually this is not a, Kinéis are not an internet service provider. They are actually an Internet of Things company. They are working on that. So with that, they are having an innovative project that with, like, it's kind of a, you can say that how our cell phones are operating. With that, you can get a location of that any cell phone wherever it is, if we have that access, although we general people don't have that access. So they are having that same kind of theory behind this project which they are launching. There, instead of having not just about the location, you will be having many others, several data to come up with, as the chairman of the Kinéis was describing, that even you can get a knowledge of the fire or any kind of other natural disasters and anything, like, so but those modules has to be present there, and those data will be fed to the satellites of Kinéis, these nano satellites, and those satellites will be relaying back those data back to the data processing centers in the ground station, and from there you can have that access of the data to know where and what things are happening. So it's not competing with Starlink, and although with Starlink competing at this stage will be really hard, as you mentioned also. Right now, as Starlinks are operating nearly around 100 countries. With the recent inclusion of Sierra Leone, they made it to up to 100 countries and territories where they are providing their low latency and high speed internet. So if someone will be starting this journey to provide internet service, it will be taking a long time to come up to the same level of Starlink today, and meanwhile Starlink will be moving more ahead. So it's not possible right now, but someone, you never know, someone can do so. Well, guys, I was checking about the liftoff time for the SpaceX Astra 1P mission. It seems like for now they are still sticking with the liftoff time of 5:35 p.m. Eastern Time, which will be 2:35 p.m. Pacific Time, corresponding to 9:35 p.m. UTC on Thursday, that is June 20th. Although according to 45 Weather Squadron, today we are having 40 to 60 probability of violation of the launch. And we are still having today the primary concerns of cumulus cloud rule and wind rule and lightning rule as well. And according to 45 Weather Squadron, they mentioned that overall the condition will likely worsen throughout the window on Thursday evening and will continue overnight into Friday. So hopefully SpaceX can make it today. Although if they will be launching on the initial side of the launch window, they have 40% of probability of violation. So maybe if they will be sharp enough, they will be making the launch at the very initial period of the launch window. But if they will be delaying, like in other cases how they do, so with those delays, it will be getting more tougher for SpaceX to launch today. So let's hope for the best. And as of now, we are at T plus 42 minutes and 22 seconds. And as we will be nearing the end of the first phase of the mission at nearly 10 minutes from now, that is at T plus 52 minutes and 5 seconds, the kickstage Curie engine will ignite. First time in today's flight. And from that point, the flight profile is custom tailored for Kinéis, as I said before. The Curie engine burn will last for approximately 2 minutes and 40 seconds. Shortly after, at T plus 54 minutes and 45 seconds, the Curie engine cuts off for the first time in today's flight. Again at T plus 1 hour and 3 minutes and 58 seconds, the kickstage Curie engine will reignite, this time the second time in today's flight. Then coming up at T plus 1 hour 4 minutes and 5 seconds, the Curie engine will cut off for the second time in today's flight. And finally, approximately at T plus 1 hour 6 minutes and 35 seconds, we will have the payload deployment completion for all the 5 satellites. As you heard before in the webcast, that today all 5 satellites will be deployed in a precise sequence, first with a single satellite and later on as pairs to build out the constellation exactly as Kinéis needs it. And finally, the Curie will conduct a perigee lowering burn to reduce the kickstage orbital lifetime to keep space sustainable. So Poptripika, you are still there. I thought with that thanks you went away. I thought that was your final thanks for the stream. But now I thank you for still being here. Now we are not so much far for the completion of the mission. So if possible, just stick around for some couple of minutes and it will be done. And finally, next we have the Astra 1P. So I'm just praying for that right now. Hopefully we will be having the launch, because each time they are delaying and postponing the launch, all those stats are getting jumbled again, and every day I'm sitting and rearranging them with those numbers and figures there. So hopefully today they will be. Thanks again for being here. And confession at 3 a.m. Are you there or not? If yes, then respond. Yes, of course, but there is a thing referring to Poptripika. I'm saying that look, with Starlink satellites, SpaceX can take chances. Even with bad weather around, they can take chances. But as it is of their customer's payload, I hope that any wise decision will be that they won't be taking any risk with customer's payload, because any unforeseen issues, it can have effect on those payload. So anyone launching satellites with customers payload should not be taking those chances. But let's see, how weather is really bad there. And according to 45 weather squadron, if they will be delaying the launch for tomorrow for the Astra, tomorrow is the perfect day for the launch, as because the probability of violation of the launch is only 20%, so 80% go is there. So if somehow they will be managing and it is possible to in their scope, in their purview, that they can postpone it until tomorrow, then tomorrow is the best day. Today the weather is average, you can say, with 40 to 60%. Let's see. And thanks for responding, confession at 3 a.m. one of our moderator here on this channel with gloomy eyes, it seems like, with that emoji. You have those crying emojis with here heart emotes to send. That's quite contradictory. Anyways, we are still at 49 minutes. So we are just about 5 minutes away from the, not even 5 minutes, kind of 3 minutes, where the kickstage Curie engine will ignite first time in today's flight. So hopefully they will be back on their webcast, still playing those musics from it. I can't take that name. Anyways. Oh, you are able to find those emojis only. Confession at 3 am. Why not? There are several other emojis. And at least you are having time today to find those emojis. Thanks for that. We are grateful that you were here before even we started the stream. Thank you for being here. Confession at 3 am.
Toulouse, our 50th Electron launch. Just about 50 minutes ago, Electron lifted off from Launch Complex 1 in New Zealand carrying 5 satellites for French IoT company Kinéis. Those satellites are now just minutes away from being deployed to their final orbits.
Yes, the Kickstage's Curie engine is performing 2 burns today to position the satellites for precise deployment. The first of those has Curie lighting up to place the Kickstage and Kinéis payloads on a circular path, what we call circularizing the orbit, and this burn lasts for just under 3 minutes. We're approaching ignition for that shortly.
This guy is reading from a teleprompter. You can easily understand from his eye tracking movements.
Curie ignition confirmed.
So we got the Curie ignition confirmed.
You heard it right there, a successful Curie ignition. This Curie burn will last about 2.5 minutes, rounding out our orbit from its current 650-kilometer apogee. We only have a few more milestones to go in our 50th launch. Curie shutdown comes next, followed by a second ignition to make a slight adjustment specific to our customer, and then finally 3 separate deployment sequences for the Kinéis payloads. They'll be about 45 seconds apart, starting with the forward-most satellite. This launch has been tailored specifically to meet Kinéis' mission requirements, giving them greater control over the launch schedule, orbit, and deployment parameters than would be possible on a larger rideshare mission.
Those tailored mission parameters for this launch include an instantaneous launch window and the special Curie burns that Prachi mentioned before. After this first burn to circularize the Kickstage's orbit, Curie will ignite again for 8 seconds to set a specific argument of perigee, enabling Kinéis to deploy 5 satellites to a precise orbit as needed. Without getting into the nitty-gritty of orbital mechanics too much, the argument of perigee determines where on the globe the orbit is highest and where it is lowest. A little bit more complicated than that, but that's why we have an expert team here guiding the mission.
Now we are awaiting for the Curie engine cutoff for the first time during today's flight. Let's hear the upcoming callouts from them.
Curie engine cutoff confirmed.
So there you have it. Curie engine has been
There we
shut off
go.
for
That's
the first
engine
time.
shutdown of the Curie engine on the kick stage. Up next is payload deployment for the first 5 of Kinéis's planned 25 satellite constellation. Each of the satellites is a 16U platform, so somewhere between the size of a toaster and a microwave, we think, and weighs around 30 kilograms, making the total payload mass of today's Electron launch around 150 kilograms. And with that Curie milestone out of the way, Muriel is joined by a pivotal team member in the development of that small but mighty engine. Let's join Muriel in mission control with Simon Moffat. Muriel?
With Simon Moffat, who has played a key part in our Curie engine on the kick stage. But I will let him introduce himself to you and tell us a bit more about the role that he has here at Rocket Lab. Simon?
Hi, Muriel. Thanks for having me. I'm Simon Moffat. I'm the manager of spacecraft propulsion and physics here at Rocket Lab.
And you have been part of the company for a very long time now.
Yeah.
How long have you been here?
It's been 8 years now, yeah. And I was an intern before that, so coming up on almost 10 years since I first started the company.
I wonder what 10 years in Rocket Lab years really is.
It's a long time.
Now, you brought a special treat for us today. Can we hold this up for the camera to see it? And can you please describe to me what this is?
Yeah, so this is the Curie engine. This is the thrust chamber for the Curie. Normally on Electron, Curie has a bit more going on. There's tanks and valves and a few other things, but this is just the thrust chamber.
Just by size comparison to the Rutherford, it is quite a small rocket engine.
It is a lot smaller. Definitely doesn't pack quite the same punch, but it's quite a precise instrument. Gets us into a very accurate orbit for the payloads.
Is there anything special about this this engine in particular? Any sort of nice ways of commemorating it that you have that you might want to tell us about? Leading question there, but
Yeah, so I mean, both of our engines are named after great scientists, and Marie Curie is quite an inspiration for us. She was an amazing woman, amazing scientist, and on the chamber here, you won't be able to see it in the camera, but it's printed in every chamber. A quote from her, which is, "The way of progress was neither swift nor easy." And that reminds us that even someone who could win 2 Nobel Prizes didn't find everything easy, didn't get everything done quickly. So makes us feel a bit better when things take a bit longer.
kindred spirits, perhaps.
Absolutely.
Is that printed on every rocket? A rocket engine, pardon me?
Yeah, that's right, on every Curie engine.
Wow, very cool. Speaking of printed, Curie is a 3D printed engine as well, is that correct?
Yeah, both Rutherford and Curie are 3D printed. Makes it a lot easier to make the complicated geometry of the chamber.
Can you describe which parts are 3D printed for me, without giving our secrets away, of course?
Yeah, absolutely. So the thrust chamber and nozzle are, and then some of the pieces in here are as well.
Very nice. Now, Simon, congratulations on launch day, of course, launch 50 for you today. How did that feel, watching that from outside of mission control?
It felt amazing. It's a little bit different than Flight 1. I think in Flight 1 we had a lot less visuals on what was going on, a lot less idea of what was going to happen. And definitely we have a lot better understanding of kind of how things are supposed to go, and obviously we're seeing things happen the way they should.
Now, you touched on it a little bit beforehand, but you've been here since you were an intern, and you've played a pivotal role in helping to develop not only Electron, but Curie itself. What other projects have you moved on to? How else have you grown during your time at the company?
Yeah, I've been really fortunate actually to get to do all kinds of different things at Rocket Lab. I even at one point did a secondment to the avionics team and worked on the flight termination system. But more recently, moving from the Curie engine and Electron, it's a very obvious progression into our space systems team and the propulsion products for our spacecraft. So more recently, I worked on the Hypercurie engine, and then after that, we've moved over to the ESCAPADE mission, which is a NASA science mission headed to Mars soon.
Amazing stuff. Can you describe
Now with this, as we are approaching 1 hour towards the 1 hour from the time of liftoff, so we are just about 4.5 minutes from the kick stage Curie engine reignition for the second time in today's flight. Meanwhile, referring to the chat, confusion at 3 a.m. I didn't run away. I'm here only, and I know you had time yesterday. And to Pop Tribeca, you are in a massive heat wave right now. You are from, if you don't mind, just I'm asking, where are you from? And these satellites won't be warning you for the heat waves. Or even it can. Technically it can. So for that you have to buy one Kinéis module, place it at your home, and maybe it will be telling you next time when the heat wave will be hitting you.
I appreciate you asking. Yes, we have several open roles right now in the propulsion team on Space Systems and the rest of Space Systems, looking for senior engineers and team lead.
How many times they will be advertising that they are hiring? Will they hire me?
And now, folks, you know who to ask for an interview. So thank you so much, Simon, for joining me. Really appreciate your time.
Thank you very much, Marielle.
T plus 1 minute, 1 hour, 1 minute and 19 seconds and counting. So nearly at T plus 1 hour, 3 minutes and 57 seconds, we will have that second ignition of the Curie engine. We are just about nearly 2 minutes away from that. Is not to forget about this, that today is the 50th overall launch for rocketlab. Which made it to have the fifth title of 50th launch faster than any other commercially developed rocket in history. They broke the record of even SpaceX Falcon. Today is the first Kinéis satellite launch as well. Out of those planned 5 launches for their constellation of total 25 nanosatellites. Again they are playing music.
Curie ignition confirmed.
So there we have it.
And Curie engine cutoff confirmed.
We got the Curie engine ignition and Curie engine cutoff.
Perfect final orbit.
We got the confirmation for the perfect nominal orbit insertion. Now here is an animation from Rocketlab.
Kinéis 1 deployment confirmed.
So we got the Kinéis 1
There it is,
deployed.
deployment of Kinéis 1. The first satellite of the Kinéis constellation is now at home. Up next will be Kinéis 2 and 4, followed by Kinéis 3 and 5.
Kinéis 2 and Kinéis 4 deployment are confirmed. Now the last pair of Kinéis satellites are left to be deployed. Just in a couple of seconds it will be done. Kinéis 3 and Kinéis 5 deployment is confirmed now. So with that, all the 5 nano satellites are being deployed with a successful Rocket Lab's 50th mission.
Congratulations to each and every person behind this launch and the 49 electrons that came before it. Making it to space once is a monumental achievement, so doing it another 50 times is faster than any other commercially developed rocket in history puts us in verified air. Now, last but not least, thank you to all of our mission partners who have flown on Electron. You have helped us to make history and create better access to space for small satellites. We are honored you chose Electron as your ride to space, and we can't wait to do it again for the next 50 launches and beyond. Now, while we're celebrating 50 launches today, we won't be pausing for long. In fact, we'll be back again soon with the next Electron on the pad. So stay tuned to our social media channels for mission updates on the next mission. But for now, we will wrap up today's broadcast and see you back here soon. Thank you for joining us, and for the 50th time, this is Rocket Lab Mission Control signing off.
So, replying to Pop Topeka, of course they did break the record here on this context, but of course SpaceX do beat them in other contexts. But we should be considering that Rocket Lab started later on, so for them it is easier to break this record which they broke today. So, but whereas SpaceX started from the scratch and they had that vision of reusability of boosters and all these things, so with that they took so many years to have research and development. So for them it took some long time, although they still, with that starting from the scratch, they made it very much with an exponential growth, you can say, much faster. So anyways, record breaking is a record breaking. We should congratulate them. So Let me conclude that today's launch marked the 5th overall launch of an orbital class rocket, that's Rocket Lab's Electron. And with that, we will wrap up our coverage for now. Also be sure to check out the social media for updates from Rocket Lab, and if possible from us also. And we want to thank all of you joining us here with today's launch, and we hope you all enjoyed the week ahead. Also, we hope that you enjoyed the stream and we could add value to your viewing experience. Once again, thanks for joining us, showing your such patience, love and understanding, staying till the end. Also, Pop Topeka, see you soon. Thanks for the after so many days you showed up, but you stayed for long, and it's always our pleasure to bring live coverages for you all guys. This is AstroYonder Live and me Dipta signing off for now, and we will see you next time.